Hey team, it's Mr. Z, and today we're going to factor expressions by factoring out a GCF. Let's review this key skill. Alright, so when you're looking at an expression, you're trying to identify common factors between the letters and the numbers. So when you're essentially analyzing this guy, you want to look at both the coefficients. I see 2, -8, and +10, and I know that all of them are going to share a factor of 2. They are all even. So the GCF of those are 2. But it's not enough to just look at the number in front. You also have to look at the variable. Here there's 5 numbers, here there's 4 numbers, and here there's 3 numbers. I can rewrite all of them to be a product of x to the third. For example, x to the fifth, I can rewrite it x third times x squared. I can rewrite x to the fourth as x to the third times x to the first. But essentially the GCF of all of these guys is going to be x to the third. So what I need to do here is I'm going to go ahead and rewrite this, but I'm going to ask myself, what multiplies to be 2x to the fifth, -8x to the fourth, and 10x to the third? My GCF is 2x to the third. So I ask myself, hey, what multiplies? 2 times 2 is just going to be 1, and then it's going to be x squared. -4 with an x, and then finally just +5. Remember, when I'm factoring out, I'm asking what multiplies to be the given expression. So I've been able to factor this first one to be 2x to the third times x squared minus 4x plus 5. But I see an opportunity. I see that here, x squared minus 4x plus 5 takes the form of a quadratic. So I'm going to make sure and check if I can factor it out. I see x squared, I see 5. If I try -5 and -1, that's going to make my +5. I'm going to go ahead and get -1x, -5x, -1x, and -5x is not -4x. So this doesn't factor as nicely as I want, but I definitely had to check. Okay, so now let's continue. Here, in the second one, you might be a little overwhelmed because it's a fractional exponent. So when I'm doing this, look at it as if it wasn't a denominator. All of these have a 5 in the denominator, meaning that I'm going to definitely be able to factor out a 5, right? All of the denominators have a 5, so the GCF is going to have a 5 in the denominator. All of the numerators have a factor of 3, so I can definitely factor out a 3 as well. Okay, now I'm going to look at the variables. It is going to include x to the squared. So this is my GCF. My GCF is 3/5 x squared. And now I'm going to ask myself, what would I have to multiply by to get my original expression? So 3/5 times -3/5. What do you need to multiply by? Well, -1. Also, it's going to need x squared. I'm going to do this again. 3/5 times 3/5 is just going to be a regular 1 with an x. And then finally, how do you make this 3 into a 27? Well, it's going to be a -9. So I'm actually able to rewrite this as 3/5 x squared times -x squared plus 1x minus 9. I'm going to, again, since this takes a quadratic, I'm going to quickly assess whether or not I'm able to factor again. Negative x squared, negative 9. And I'm going to ask myself, hey, I know x times negative x is going to produce negative x squared. I know that the factors of 9, well, I'm going to try 3 and negative 3. So when I multiply it out, this becomes 3x, this becomes 3x. Do I want 6x? No. Notice how it's a 1x? I want 6x. So I'm going to try something real quick. I'm going to go ahead and adjust the negative. I'm going to make this positive and make this one negative. And I get a negative 6x. I want 1x. This isn't really working. So I'm going to leave this as this form. It can't be factored over real numbers. So this is just a review. Basically, you want to factor by using a GCF. You need to analyze what do they all have in common. And the idea is that you always want to do that second glance. In both of these problems, I wasn't able to factor further on, but you always got to check. So that's it for now. Ciao.